Hi folks, we are back with another video and looking at lesson 1 and 2 today. With the beginning, we're just going to go over some lesson 1 stuff. I'll talk a little bit about lesson 2 stuff. This isn't meant to be a replacement for a full lesson. I'm just using this time to share with you what I think is the most important aspects of the lesson based off of what people ask me questions on, but also based off of what I talked about in the office hours, which I'm hoping to see more of you in the coming days and once we all kind of get used to and get back into the swing of things, because I do think it is quite important that you all come to those office hours because there's a lot of good learning happening there when you are all there. That didn't make sense. We're going to cut that. Okay, maybe not. Who knows? So when we look at lesson 1, I just want to talk a little bit about the idea of what electromagnetic waves are, because there were a lot of really good questions that talked about wavelength, frequency, what is the difference between those two. I'm going to talk about that today with you. So when we look at the visible light, it's the light we can see. We group all of these forms in what's called electromagnetic, the electromagnetic spectrum or the EM spectrum. I'll talk a little bit about that afterwards as well, but it's very, very important that we understand that they're both electrical components and magnetic components there. So these waves are energy, but we can compare them to water waves just like below, and unlike water waves, electromagnetic waves are a form of radiation. That means that they do not require a medium or a physical substance to move through. Remember, from astronomy last year with grade 9, light can move through space because light does not need a medium. All right, a lot of people asked about what is wavelength and how can we use our understanding of wavelength to kind of help our understanding of light as a whole. Recall, the energy of motion is called kinetic energy. Energy is moving from left to right in this diagram below, and the object is moving up and down. The general picture of a wave shows the important characteristic of what's called wavelength. So wavelength is from one crest to the other. All right? That's how we measure wavelength, that distance between the peaks. And the reason that's so important is because when we look at wavelength in the context of the electromagnetic spectrum, and this is what a lot of people were asking about with regards to the low frequency, high frequency, long wavelength, short wavelength, as the wavelength gets shorter, the frequency increases. And likewise, as the wavelength gets longer, the frequency decreases. So I zoomed in on this in the office hours the other day. I'm going to do it again. When we look at how long that wavelength is, how long that wavelength of radio waves are, it has a very low frequency. It takes a long time from one wave crest or peak to the next. It takes a very long time to get there. So as a result of that, we say that it has a low frequency and a long wavelength. Likewise, with regards to something like gamma rays, we have a very short wavelength. The distance between the tops of that wave, very short, and that means it goes through a lot of oscillations very quickly. So we say that it has a high frequency. And then we talked a little bit about visible light. I'm going to talk more about that with regards to the lesson 2 component. So the only waves of electromagnetic spectrum that we can see are those in the visible light spectrum. They're a very, very, very tiny fraction of that EM spectrum, and we can only see a little tiny fraction of it. One more thing, the longest wavelength of visible light is red, has a very long wavelength, therefore a very low frequency. And the shortest wavelength of visible light is violet, which means that it has a very high frequency relative to the rest of those colors. And then white light contains all the colors of the rainbows. We talked about it in the office hours from Thursday with regards to the difference between the two, why lasers produce no other colors when shot through a prism versus white light, and I'm going to talk more about that now.